Hey, I guess we are online. Let me mute the. Actually, if I mute it, then I won't be hearing the notifications. So let's go on. Hello, everyone, and let me present. It's such an honor to be here, and hopefully you will get something and you'll like to talk. My name is Murat. I live in Mountain View, California. I work as an Android developer advocate at Google. And today I have an interesting topic. I'll be talking about Java and Kotlin and how they get along with each other. Enough chit chat, let's dive in. So as if we had one language was not enough and we had already mastered it, now we have two languages. And it doesn't really matter if you really want to stick with one, because a library or another module might be using the other language, and you still need to interop with the other language. It doesn't matter if you stick with Java or Kotlin, you still need to call the other language from yours. So that's why let's take a look at how we call Java from Kotlin and Kotlin from Java. Let's start with calling the Java programming language from Kotlin. The first topic is nullability. Nullability brings some question marks. This literally, it's funny because you need to add question marks to point a variable or a reference can be null. This is because Kotlin doesn't have nullability as default. When you do this, this is a side effect of Java having nullable types and Kotlin have non-nullable types as default. But when you put the question mark, you feel like you're doing something terribly wrong, as if, and most of the time you don't have any other option because you need to mark that variable or reference as being, which can be null. But it kind of gives you a feeling like you're doing something terribly wrong. You're ashamed of your coworkers, colleagues. Let's take a look at what we can do to make your API more friendly from Kotlin, so people don't need to add question marks for fields. To do that, actually, what you need to do is something really basic. You need to annotate all non-primitive parameters, field types, and returns with nullability annotations. Let's see what are nullability annotations. We have a long list of available annotations which can help your case. We strongly suggest using JetBrains annotations. That's what we usually do. Android annotations are also fine. GSR 305 is discouraged. If you have a burning desire to use it, sure, go ahead, it will work, but it needs some configuration. You need to add an opt-in flag to be honored by the compiler, to be not conflicting with Java 9's module system. But in general, try to stick with JetBrains and Android annotations. So let's take a look at an example. A talk without code is not a real technical talk, right? So this is an API written in Java. The first line, it basically gets a collection of elements and converts it into a set. If you try to call this from Kotlin, you need to add the exclamation marks because Kotlin has no idea if the input and the output is null or not. They can be null, so it expects a nullable input and expects a nullable output. This is because, once again, Java, any reference can be null, while in Kotlin, it's optional. However, if we go ahead and change our Java code with add our annotations to our Java code, then the Kotlin call gets much nicer. You don't need the exclamation marks, and you can just call the API right away, because now we are basically telling Kotlin, okay, we are handling this, and the input will not be null, and the output, which I'll be returning to you, will not be null. Next, we have property prefixes. So if you're following Java Bean style, a very quick summary, if you're following Java Bean style, you should be fine because Kotlin knows how to invoke the Java getters and setters. To give an example, let's say we have a user class and it has a getName function for the name parameter. When you try to access this name over the property name from Kotlin by calling user.name, Kotlin knows to invoke the getter, the getName function. This is only true if your getter starts with get and followed with the field name, property name, and doesn't have any input. If you break this contract, Kotlin cannot be calling the getter. Setters are similar. Again, you need to obey the contract. So a setter should be a single argument method with the name starting with set. Once again, if you invoke the name function by assigning a value, name parameter by assigning a value, Kotlin will know how to invoke the setter and call setName function. This is also true for is. So if you're using is, such as in this case, the user has a Boolean field is active. Once again, if you try to access the property over property name active, Kotlin knows which function to call. Cool. Let's move ahead and take a look at keywords. So Java actually did a very good job with not introducing a new keyword for a very long time. I've been programming with Java for all my life, and the main real change I remember is in 2005. When the enum keyword was added to Java, then we needed to remove any function or parameter name with enum to something else, because now it was a reserved keyword. And the one before that was in Java 1.4 when the assert keyword was added. There are new additions with Java 9 and 10, but in general, Java did a very good job not introducing a new keyword. And Kotlin is actually not breaking anything here, but Kotlin is a new language, so Kotlin has its own reserved keywords. So this is not actually about a big change or anything, but making two languages work with each other. So let's take a look at an example. So Kotlin has a variety of reserved keywords such as fun, in, is, object, type values, so on. And if your Java code uses one of those as a function or parameter name, this is perfectly valid for Java, but not for Kotlin. In this example, I have a function called is, which is a terrible name. Don't do that. A function named is basically tells nothing to the user about what it is doing. But still, let's imagine we have such a function. And the best way to fix this is actually rename the function. If you rename the function to something more specific or something not a keyword, then Kotlin users won't be having an issue calling the function. Once again, if we go back to the initial state of this function, once a Kotlin user is trying to access this function, they will get an error because this is a reserved keyword, as I mentioned. So what can you do apart from renaming? Because you can be author of a library which has been widely adapted and used, then you may not want to break all your existing users and introduce a new keyword, introduce a new function name. So in that case, if you really need to stick with your function name, actually Kotlin users can still call this function by using backticks. So backticks is kind of a escape mechanism. When you put backticks, Kotlin knows this is not the Kotlin reserved word anymore and knows it needs to call the function is. Actually, this is a real case. Sorry for that. This is a real case. The Mockito library uses when as a function name, which makes perfectly sense for Mockito case, but it basically breaks Kotlin side. So in short, try to avoid these names. If you have to, you can use it, and Kotlin users have a way to escape. But remember, it took us more than a decade to get rid of the semicolons. So you don't want to introduce a new character to all your users and want to make them type more. That's why try to pick a function or property name without the reserved keywords. Next, we have extension names and properties of any. This is not actually something which will break your code, but more like a guidance to make things simpler. Avoid using extension names and property names on any when you create your own extension functions. Why? Because actually everything will work because Kotlin knows how to give precedence over your extension function over any's. However, it still makes your users very confused. Someone will not know if the, for example, apply is coming from any or your extension function on some object without actually really diving into the code. So again, try to avoid using these as extension name and property names. Next, we have operator overloading. This is a super fun topic. Java never had operator overloading, and it was for a reason. Java came after C++, and at the C++ era, operator overloading was really abused. Because Java doesn't have operator overloading and Kotlin has, it might have some side effects. Let's see how operator overloading works first. So if you use plus sign, what Kotlin does is it looks for a plus method and invokes that method instead. So if you have overridden and implemented a plus, minus, or times method, and if the operator is used on two objects, Kotlin knows which function to call. Let's see this with an example. Arabic numbers are very easy, and all the world is happy with that. But let's imagine a world where we need to use Roman numerals in our app. And I want to add Roman numerals by using the plus sign, but of course, Kotlin will have no idea about how to add two Roman numerals if I don't help. So to help Kotlin, I implement a plus method. The plus method will do something really simple. It will convert the Roman numeral to decimal, add them together, then convert the result back to Roman numeral. Once I implement this method, I can basically just use plus sign, and Kotlin will go back and call the plus method we implemented. So this is super useful in such cases, but always be careful about operator overloading, because operator overloading can easily be abused and if it's used in a wrong context, can complicate things rather than helping. Always remember, Java had a reason not implementing operator overloading at the time. And hopefully, we Kotlin users this time make be more careful about how we use operator overloading in Kotlin. So the next language still wants to implement operator overloading. Next, we have SAM, which stands for single abstract method, or in a simple way, they're functional interfaces with a single one method. So for Java, Java takes an anonymous implementation and converts it to meet the interface required. This is only possible when there is one method in the interface. And as you can see, this runnable interface can be just invoked without using the run. And calling from Kotlin, Kotlin supports function literals, supports SAM conversions. This means Kotlin function literals can be automatically converted into implementations of Java interfaces with a single non-default method. Of course, the parameters need to match between two. Then, basically, that means when you call a Java method from Kotlin and the method satisfies conditions, you can pass a lambda and or method reference, and things will work in a very nice, simple syntax. The main rule here is the parameter types which are eligible for SAM conversions should be lost. Let's take a look at an example. So we have a calculate function here, and it takes 3 parameters, 2 integer numbers, and an operation. And our operation here is eligible for SAM conversion. If we call it, if we don't place the operation as the last parameter and try to call it from Kotlin, it works. The syntax doesn't seem perfectly fine, but there's no errors. However, if we replace the order of the parameters, then things get much nicer. You can see you can just pass the integers and then add your lambda operation as a lambda parameter, and looks much like native Kotlin. One thing to note here is SAM conversion only works for Java interoperability. What that means is if you define an interface in Kotlin with a single method and a function that takes in the interface as a parameter, if you try to invoke the function with a lambda expression, you will get a compile time error. Instead, you can pass an anonymous object which implements the interface. The reason SAM conversion doesn't work in Kotlin is because Kotlin supports function types as first-class citizen. So this conversion is not really needed. If you change the parameter of the previous function to be a function type like this, then good old lambda expressions work without a problem. With that, let's move to a slightly more complex situation that may not be clear at first. Here, the interface is defined in Java, and the function is defined in Kotlin. Although this looks like it would work, it doesn't. Actually, you're still calling Kotlin function from Kotlin. So SAM conversion is not supported here. The rule of thumb is as long as your function is defined in Kotlin, you cannot use SAM conversion if the parameter is an interface. With that, we have the rest of the talk, which is calling Kotlin from Java. Let's dive in. Let's say you have a utils class in Java and you have several static utility functions. We all use this. It has a private constructor, so we basically don't want any instance of this util class, but we use it to store all the static functions. When we want to move to Kotlin, we don't usually do that. We have extension functions, and instead of putting a utility function which is related to date into another class, we can just create an extension point on the date object and implement our function there. But how Kotlin works is actually Kotlin generates a new class which is called dates_kt, and it's our function, our extension function as a static method to there. This doesn't work with your existing Java code because your existing Java code is still calling utils, and Kotlin has created a new class, and Java doesn't have any support for extension functions. So to fix this, what you can do is if we go back to our extension function, you can add an annotation at file JVM name and declare your file name. With this, Kotlin knows how to rename the file, so the Java code, the existing Java code using this function doesn't need to be changed. Also, if you need if you have more than one file, you can use the JVM multi-file class annotation. So with this, you don't need to do any change on your Java code, and your Java users can still call the function over utils class. Let's take a look at another topic. So we already saw the bean conversion, right? So for Kotlin, Kotlin will create getters and setters for these properties, and Java knows how to call them because the functions exist. And for Kotlin, again, Kotlin will do its magic. But what if you need to access the property, such as accessing the text here? In that case, you need to add the JVM field annotation. With this annotation, Kotlin knows it needs to expose this field as a public field, and any caller who wants to access can access this field. But you cannot use JVM field with something like this. This is not a property, this is a getter, so this will not work. Another thing to note, late init variables are automatically exposed, so you don't need to add a JVM field annotation on top of those. So let's see. Also, I was trying to remember this slide. Also, constants are automatically exposed, so make sure you don't try to add any annotation if it's a constant field and you want to expose the field to Java. So now let's take a look at another data class. In this data class, again, Kotlin will generate all the getters and setters. But what if we want to use different names? Like in this case, get like Spring, set like Spring. This doesn't sound really fun. And I want to use something like, okay, like Spring. So I can just call is my user like Spring and do something else. To do this, you need to add the get JVM name and declare your name. With this annotation, you're basically telling Kotlin to generate the function name with the name you choose instead of the automatically generated ones. Similarly, instead of set name, we can use change name, which may make more sense in some cases. So instead of invoking the setter, trying to find the setter, you can use the change name function. And this will be the code which Kotlin will generate. You can see change name and likes being instead of the default getter and setter. Now let's take a look at something else. Here we have some static methods. So when this is converted to Kotlin, you cannot call this as you used to. What happens here is, actually this is how we're taught, right? If you have a static function, create a companion object and put the static function without the static keyword, because Kotlin doesn't have static, into that companion object. But when you want to call this from Java, you need to add the companion keyword. So instead of calling my service schedule, you need to call my service.companion.schedule. And although this is not too much, you still need to change the existing Java code, which is not what we want. So instead of this is a side effect of how Kotlin works. So when Kotlin compiles the into bytecode, it gives the name companion to this companion object because it doesn't have a name. And to fix this, what you can do is, again, add JVM static. When you add JVM static, Kotlin compiler knows you want to access this field as if it's a static field. And now you can access this over my service.schedule without using the companion object name. To use JVM static, JVM static can be only used on functions and properties of companion objects, functions and properties of named objects, and you need to be using Kotlin 1.3 and above, and your JVM target should be 1.8 and above. Let's see another interesting topic. So, Kotlin has default parameters, which means if you don't pass the interpolation parameter here, Kotlin knows the default is not none and uses that instead. But Java doesn't have that. So what will happen if you try to call this from Java? Well, you will get an error. To fix this, you will get an error. So to fix this, what you can do is you can apply the JVM overloads annotation. This annotation creates all the combinations of this function starting from left to right. So with this, you can call the function with just your scale parameter, and you don't need to pass the interpolation because Java already created all the overloads and know which one to call. Let's take a look at how, oh, yeah, I was missing this one. The other thing is when Java creates this overloads, the naming, you also want to tweak the name because from Kotlin, you can use this as an extension function, but on Java, because that will be a utility function in a class file, the naming may not make sense. Calling bitmap resize from Kotlin is pretty self-explanatory because you're calling the resize function over on bitmap, but calling utils.resize doesn't give really much context to a Java user. So in order to do that, fix that, again, you can use the @java name annotation and declare a name. With this, Kotlin will generate the function name with the function name you choose, so the Java users can invoke the function without having trouble to understand what it actually really does, such as this one. Now let's take a look at another example. What about exceptions? Let's say I have a chat stream and I'm trying to handle the IO exception, which can occur anytime during the chat. But as you can see, Kotlin doesn't actually has checked exceptions and declare an exception like I'm throwing this or that. So from Java side, when you try to do that, it doesn't make sense for the compiler because there's no exceptions being thrown from the called function. How can we fix that? So if you go back and annotate your function with it throws and the type of the exception it throws, then Kotlin compiler generates the right class file to tell Java this function is actually throwing an exception, and such as this one. And from now on Java, you can just check your exceptions and write your code on top of that. We have one more thing. So this is a very interesting topic, feature leak prevention. This kind of a side effect. Let's take a look at a function in Kotlin. Here, the name parameter is passed to intrinsics for checks, and because this name is passed here, ProGuard will not be able to strip it out and change it, obfuscate it. So basically, if you have a secret or key or something else used in this way, which you want to be keep as a secret, it will be in plain text in your bytecode because ProGuard will be careful about not changing it. And you can easily leak this if someone tears down your APK and reads your code. So what can we do? This is also a case if oh yeah, this is the generated Java code, and you can see it basically keeps the string as it is. So the same is also true for method names. So in this case, Kotlin cannot verify if because how the Kotlin compiler works, it still needs to check the parameter if it's not null, and this basically means it needs to add the secret feature as a name with the $signs added into a check. And with this, again, you will be leaking the feature. But how can we prevent that? Let's take, oops, I passed the slide. So to fix this, actually, I really strongly suggest you to take a look at the full list of all functions in Intrinsic's Java source code. That's basically the source of truth of how the checks work and other renaming stuff. The main thing you can do is you can use ProGuard rule, assume no side effects, to let ProGuard remove the checks if you're fine with that, which will stop leaking the names and keep your code safe. So today we take a look at nullability annotations. These are probably the easiest things you can fix in your Kotlin code. You can just add the annotations and all your Java users will be calling your Kotlin code. All your Kotlin users will be calling your Java code in a nicer and more Kotlin-friendly way. We saw how property fixes works and how to actually change them. We saw the language keywords and how to avoid using them. Also, extension function and property names on any. Another interesting topic was operator overloading. Make sure when you do operator overloading, it makes sense and you're not abusing it. Don't try to add two users together. But yeah, if you have Roman numerals or other properties which actually can be added together, go ahead and implement your own operator overloading functions. We saw how single abstract methods work, and then we moved to Kotlin side and how we saw how to make Kotlin friendly to Java by using Java name, Java fields, Java static annotations, as well as Java overloads. Then we take a look at how to handle exceptions in a language which doesn't have checked exceptions. Again, this is something very interesting because Kotlin doesn't have it, and Java has very strongly has checked exceptions. And finally, I give a peek of how you can make sure your strings, which you think will not leak, can leak into bytecode and how to prevent that. With that, the slides are over, and I'll be very happy to answer your questions. So let me go back to the room. Am I missing any questions? I'm trying to go through the list, but sorry, I don't know much Arabic, so I may not be catching everything. Cool. No technical questions so far. In that case, I can assume everyone is happy with working both in Java and Kotlin side by side, and hopefully the talk helped in understanding more. Cool. Thank you very much. It was such a pleasure to be here. I wish I could see everyone face to face and get your questions face to face, but I guess that's how we need to live for a while, and see you next time.